So in this video, I'm going to teach you how to do U-substitution. So recall the chain rule. If I have a composite function where it's capital F of, and then it's composed of g of x here, to take the derivative of this function, I take the derivative of the outside function, capital F of x. The derivative of capital F is f capital F prime. And then I have my inside that goes in here. And then I multiply that by the derivative of the inside function. That's the chain rule. And so the derivative inside g of x is g prime of x. So I can simplify this, replacing capital F prime with lowercase f, as long as capital F prime of x equals lowercase f. Okay? So the derivative of the antiderivative is equal to the integrand function itself. So what does this tell me? The derivative of capital F of g of x, composed of g of x, is little f of g of x times g prime of x. So I'm going to integrate with respect to x on both sides. And when I do this, the derivative and the integral cancel each other out. And this just equals f composed of g of x plus c. Okay? So this is how we integrate a function of this form, where I see a function and then its derivative sitting out to the side, dx. So let's do this in general. Okay, I'm going to go through step by step. So 4 steps in doing U-substitution. So U-substitution, this is the first of the integration techniques that you will learn in Calculus 2. So this is where we're going to end with Calculus 1. And we'll pick up where we started with Calculus 2. So rule number 1, I want to pick a u. That's the inside function. So the inside function here, my g of x, I want to pick that inside function. So I pick my inside function. I see here that the inside function is here and its derivative is sitting out here. So I replace g of x with u. So I'm going to replace this g of x here with u. And then I have left g prime of x dx. This u here is known as the inside function. Step number 2, after I pick a u, then I try to compute the differential. So I take the derivative of u and I get du. Okay? The derivative of g of x is g prime dx. That's the differential. Number 3. Transform the integral into u's only. So since we're making a u substitution, here we're going from x's and we're going to turn it into all of u's. Okay? Now, sometimes we can and sometimes we can't do this. If you can't get rid of all the x's and dx's, okay? So like in this example here, we've got u's, which is good, but I've got an x here and an x there. That's no bueno. All right, so if you can't get rid of all the x's and dx's, then you picked a bad u, okay? When you pick a u sub, you should be able to transform everything in terms of u. So you keep trying new u's until you get it, okay? Maybe you can't find it, and then therefore a u sub won't work here. But for the last problems we're doing in Calculus 1, everything can be solved with a u substitution. All right, that's the only technique we have besides just our regular rules that we have, okay? So I have f of u, that's in terms of u, but then I need to get rid of this g prime of x dx. Well, what do I know g prime of x dx equals? It equals du. So I'm going to replace that with du. So now I have an integral completely in terms of u only, u and du. The last step is to solve the integral. So if I integrate f of u du, I get capital F, the antiderivative of lowercase f, plus c. And then the last step is to write your answer back in terms of x. If we start in x, we need to end in x. Right now it's ended in u, so I'm going to replace everywhere I see a u with what? G of x. And voila, I have my answer. So that's the theory behind U-substitution and why it works. Now what I want to do is show you the practice in doing a real example here. So let's do this example. Now step 1 says pick a u equal to g of x, and the u is the inside function. Now out of these 2 or 3 or 4 options here, what looks like the inside function? Well, it looks like I have something raised to a power, okay? And that's a good sign that this something is the inside function here. So I'm going to pick u equal to x cubed plus 7. That's my u that I've chosen. Could it be wrong? Absolutely, it could be wrong, okay? Now, once I get my u, step 2 says compute the differential du. So I need to find du. To get du, I take the derivative of x cubed plus 7. Derivative of x cubed is 3x squared, and the derivative of 7 is 0. Okay, so it's not just the derivative du dx, it's actually the differential, so technically this differential comes in over here. So what do I notice? This right here is right here, okay? So I see that I can replace 3x squared dx with just this du, okay? And then I also can replace x cubed plus 7 with u right here. So another way to know that it's a good u is if I see the thing that I think is my inside function, which I thought this would be the inside function, and then I see the inside function's derivative sitting out to the side. That's a good way to know what's u and what's du, okay? So I see a function on the inside and then its derivative sitting on the outside. That's a good pick for u. So now that I have this, I can substitute. I have this is equal to u raised to the 19. So I'm going to put u to the 19. And then the rest that I have left to substitute, 3x squared dx, this gets replaced with du. And now all I have to do in step 4 is solve the integral, because I'm completely in terms of u now. Step 3 is completed. And to integrate u to the 19, I take 19, I add 1 to get 20, and I divide by it to divide by 20, and then I plus c. But the last part of step 4 says write the answers in terms of x. So what do I know u equals? U equals x cubed plus 7. So I'm going to replace the u with x cubed plus 7 raised to the 20. So I should have a 20 there. All right. Okay, over here, I see I've got another U-substitution problem going on here because I don't have a rule for products yet. So what I'm going to try is a U-sub to change this to be in terms of u instead of in terms of x. Step 1 says pick an inside function u. So I could pick cosine x, I could pick e to the sine x, I could pick sine x. Those are all options. I'm going to pick sine of x to be my u, okay? You know what? What if we just pick u to be cosine of x? Let's do the wrong one, and maybe we'll see, what I'm talking about if you mess up. So I pick u to be cosine x. Du is equal to negative sine x dx, okay? So what have I done here? What I can substitute is I can replace cosine with a u, and then I have e, oh my goodness, e to the sine x dx, right? Well, if I divide both sides by sine of x, negative sine of x, I have du divided by the negative sign of x equals dx, right? So I can replace this dx with this here, and that gives me integral u e to the sine x du over negative sine of x. Okay, what's wrong here? I have u's here, but then I also have x's here, and that exponential doesn't cancel with this denominator here. Okay, so I don't have it fully in terms of u in this integrand here. So since I don't have it in terms of u completely for the integrand, then I know I picked a bad u. Okay, so that didn't work for us, so we got stuck. So now we need to go back to the drawing board. So cosine x didn't work. Let's try another u. Let's try u equal to sine x and see what happens. If I choose u equal to sine x, then du is equal to cosine x dx. That's differential. All right, and what do I know? This cosine x dx can be replaced with du, okay? And then my e to the sine x can become e to the u. So I have e raised to the sine x is equal to u. So I'm going to put u there. And then my du replaces the cosine x dx from my differential I calculated here. So now I have an integral completely in terms of u, so 3 is complete. Now I need to integrate e to the u du. E to the u is e to the u plus c. And then I replace u to make it in terms of x again with sine x. So that's my final answer right there. So hopefully this kind of gives you an idea on the step-by-step how to solve using U-substitution. Step 1, pick a u where it's the inside function where you see the inside function and its derivative okay, or a constant multiple of the derivative, okay, sitting on the outside there. So we'll talk about how we can adjust our du in order to make it fit into our substitution for the integral in terms of u in another video, but not only would a constant or the derivative itself work, but a constant multiple of the derivative would be okay too.